BGP message and neighborship states. In this video, I'm going to talk about the BGP message and after that neighborship states. BGP uses four types of main messages. These main messages are first, open message, and the second is the update message, and third is the notification, and finally the fourth message is the keep alive message. Okay, these are the main messages BGP uses. First, what is the open message and what is the usage of open message? You know that BGP uses open message to set up and also establish BGP adjacency or BGP neighborship. This is the usage of BGP open message. What is the usage of update message? I will talk about update message in the future videos. With after update message, BGP advertises or updates or withdraws routes. For example, R1 connected to R2 and we have a neighborship, for example, eBGP neighborship. R1 with the update message, okay, can send to R2 an address. Maybe R1 connected to net A and R1 can send BGP update. And in the update, you know, we have NLRI, as I mentioned before. And in the NLRI, network reachability information, R1 sends net A to R2 with some attributes. This is the advertisement or the first advertisement. After some second, maybe we have a change in net A. For example, one of the parameters for net A now is changed. We can send another BGP update and updates the information about net A. Or maybe, for example, net A now isn't available. Because of that, R1 should update the R2 at that the net A in this time isn't available. Or withdraws routes. Withdraw means that R1 withdraw the route that previously advertises to R2 and says to R2, in this time I don't have the route for net A, withdraw that route. Okay, all of these concepts and all of these functions can be done with the BGP update message that I will talk about the BGP update message in the future videos. And then notification indicate an error condition to a BGP neighbor. Indicate an error condition to a BGP neighbor or BGP peer. We call BGP neighbor or BGP peer. Okay, and finally keep alive. You know the keep alive now ensures that BGP neighbors are still alive. Ensures that BGP peers or BGP neighbors are still alive. And also I want to inform you that in the recent iOS, BGP added some other message. I will talk about all of them in the future videos. But for the BGP from the first days until now, BGP uses these four main message: open for neighborship, update for advertising updates or networks, notification for indication and error condition, and keep alive for ensuring that BGP neighbors are still alive. Okay, very good. These are BGP messages. The next topic that I want to talk about that is BGP neighbor states. We experienced some states in the previous videos. For example, you saw idle state or maybe idle admin. Okay, when we use neighbor IP shutdown, we saw idle admin state. This means that administratively idle state. And also in one of the scenarios that I configured before, we see for some second active state. And also you remember that we talk about the established state. Okay, but these three states are not all of the states that BGP has. Because of that, in this section, I want to talk about the BGP neighbor states. First things that I want to mention is that in BGP, we have 6 states. First, idle. Second, connect. Third, active. Fourth, the open sent. And fifth, open confirm. And finally, established. Okay, but maybe you ask me what engines or what part of the BGP should carefully use these states and ensures that now BGP in what state and inform that to the neighbor, that to the administrator. BGP forms a TCP session with neighbor routers. Okay, you know it. And we call the neighbors as peers. BGP uses the mechanism, we call it finite state machine or FSM. BGP uses the mechanism, we call it finite state machine or FSM, okay, to maintain a table of all BGP peers and their operational status. For example, maybe R1 connected to R2 and R2 also connected to R3. And now we have the idle state between R1 and R2. Why? Because, for example, the authentication didn't pass between R1 and R2. And also between R2 and R3, we have established state. Okay. This is the FSM that maintain a table for these states. For example, when you use this command in R2, show BGP IPv4 unicast summary, okay, you can see R2 now has 2 neighbors. First neighbor is R1, okay, and the state is idle. This is not the neighbor, this is only a record, you know it. And also R2 has a real neighbor, complete neighborship with the R3, and the state now is established. Okay, this is the function or the job of FSM that can maintain for all of our neighbors the state. Okay, let's talk about these states, and when we are in the idle states, what should occur or what is occurred, or when we in connect state, what does it mean, and again active, open send, open confirm, and established states. Okay, let's talk about these features. First, you should check this diagram. You can see that in diagram we have a we can see the process of BGP neighborship in a complex diagram. Okay, BGP neighborship states, and we should go from this place. Now we are in the idle state. This is the first state, and this is R1. For example, I want to talk about what is happening for R1 to be neighbors with R2 if everything is okay. But and also what is happening for R1 if some things in the neighborship process is going to, for example, wrong state. Okay, we want to talk about all of these details. First, we should understand the idle state. You know the idle. Idle is the first stage of the BGP FSM or finite state machine. Because of that, we should start from the idle. BGP, when we are in the idle state, for example, R1 in the